In this question, we're told that we have a cord running down two massless, frictionless pulleys. A canister with a mass m equal 20 kilograms hangs from one pulley and you can exert a force F on the free end of the cord. The first question, we want the magnitude of the force F if you are going to lift the canister at a constant speed. So we want to find the force, and we're given that the speed is constant. If the speed is constant, we know that the sum of forces should be zero. And if we look at the forces we have here, well, the force F is downwards, is applied downwards on the rope on this side, and opposing it is the tension. So we know that F is equal to this tension. Now, we can find this tension by studying the forces right here on this pulley. So we can see that we have two tension forces which are upwards and the weight which is downwards. And we can see that all the tensions here are equal because they are all across massless pulleys. So for the pulley, the sum of forces is also zero, and the forces that we have here are two tension forces minus the weight, which tells us that 2t equals m times g. We can use m, which is 20 kilograms now, to find t. And this will give us 98 newtons for the tension, and F has the same magnitude. In part B, we want to know how far must you pull the free end of the cord to lift the canister by 2 centimeters. So we want our object here to be lifted by 2 centimeters, which means that on each side of the rope there should be a lifting of 2 centimeters. And then this means that we need to pull the rope on the left side by 4 centimeters in order to establish this lifting. So in part B, we know that the two segments of the cord on the right must be shortened by 2 centimeters to lift the weight by this length. So the left side of the cord should be pulled down by 4 centimeters. In part C, we want the work done on the canister by your force via the cord. So we want the work done here by the applied force. We know this is going to be F times D, and we know that the force was 98 newtons. And the distance here is during pulling the cord, so during that lift, which means during pulling the cord by 2 centimeters on the right side for each segment and 4 centimeters on the left side. So this is 4 centimeters on this side where we are applying the force, and this gives us the work to be of magnitude 3.92 joules. Part D, we want to find the work done by gravity on the canister. So the work done by gravity is going to be also the force itself times the displacement. which is mg times d. And this is negative because the weight is going to resist this upward lifting of the mass. So we have minus, the mass is 20 kilograms, this is 9.8, and the distance in the right side is 2 centimeters, right? So this is 0.02, and this gives us the work to be minus 3.92 joules. And you can notice how the work done by each force is the same. So actually W net is going to be 0, and thus the speed is constant. I also deduce that the speed is constant during lifting. So here we were able to do this study of lifting this mass of these two pulleys and studying the displacements on each side and then finding the work done.